Uh, Now I am explaining the leak code number 403, frog jump. This is a simple breadth search solution. Um, okay, first let's read the question. We have a ascending, yeah, we have a set of stones in ascending order, right? So this is in ascending order. And if frog's last jump was k unit, the next jump must be either k minus 1 k or k plus 1 unit. And also given that the frog can only jump in the forward direction. So we have some implications here. So if we have more than one stone, right? If we have two or more stones, right? Then the second stone must be one because the frog can only jump in the forward direction. It cannot stay and it cannot jump backwards. So if we have two or more stones, then the second one must be one, right? And starting position, of course, is given. It's always 0. So with these implications, we can have some check conditions here. So if the size is less than or equal to 1, then it's true. And if the second stone, the index 1 stone is not equal to 1, then obviously it is false. And if we pass this check condition, if we have 2 stones, then it is true. Uh, so, uh, like similar to all other breadth search problems, we have conditions to check, which is here, the islands, and we have the if is visited set, and this is for cutting the tree branches for the breadth search. And here we're just adding everything from stones to the island, and we have the target. Okay, and so here's the queue for breadth search and starting position because uh, we already passed the check condition above, so we can start from 1 instead of 0. So okay, here the size is just templates for the breadth search, but importantly here uh, is we are declaring some variables. So int p means this is the using the previous jump force. So which is here, we are maintaining the k. We are not subtracting. We are not adding 1. So this is using the previous jump force, and we get that result, right? And so this means the previous location, and this is the previous jump force, and we add that together. That is the result we are achieving using the previous jump force. And this is basically a tuple that keeps the next keeps the next point. So the next point is using the previous jump force result and the previous jump force, and we are just adding the points into the queue and into the visited block. So like why the visited block is we have to use the tuple, not a single distance, is because if you only have the distance, then you may have jump from the k1, not k2. So you may jump from the different force. So So even you reach here, you can lose other possibilities. So okay, let me explain in here. So all right, so if your position is in maybe like 80, right? But the jump force is 60. This condition is different from the position is in 80, but jump force is 40. Uh, because like the next jump can must be k minus 1, k or k plus 1 units. So the previous jump distance is important. So we have to put that into the visited, take that into the consideration. So yeah, so we do. And similarly, we have the short jump force, which is the previous jump force minus 1, and we have a long jump force result. And we just push to the queue and we insert into the visited. And eventually, if we we pop an element from the queue, and the element we are popping has the 0 index to be the target, then it is true. If we pop that queue to empty and we didn't have this check condition to be true, then obviously it is false. So this is a really, really simple solution. So let's check. And obviously it passed. Yeah, thank you so much. That's everything.